Okay, we left off from here. All right, so starting back from number 6, HA is given to you. The alternative sigma is different than 11. So our first choice is A. We're matching it. Why? Because this only works. Why? Because this statement, sigma different than 11, means that sigma could be less than 11 or could be greater than 11 as long as it's not 11. So B and C wouldn't work. So A is the choice. So we know that the null has to be equal to, because it's the complement of different than, yeah, equal to. And finally, if it's equal to 11, so D is the only thing that works, right? Because it has to be 11. It cannot be less. It can be greater. It cannot be anything and 11. So the choice has to be D. Does that make sense? I hope so. Let's look at number 7. 7, it says a null and alternative hypothesis are given, right? So this is equal. Determine whether the hypothesis test is left tail, right tail, or two tail. If you remember from your notes, you know that you can have this is the nature of your test. Nature of the test. You can have a left tail test. So if you have a left tail test, it means that the alternative contains the less than sign. If it's a right tail test, it means that the alternative contains a greater than sign. And if you have a two tail test, it means that the alternative contains a different than sign. Okay? In this case, your alternative is a different sign. So it means this is a two tail test. The nature of your test. So if you remember from your notes, nature of your test, you look at the alternative always. The alternative is what gives you the nature of the test. Whether you have mu less than some value, mu greater than some value, mu different than some value. So this is a two-tail test here. This is a right-tail test. And this is a left-tail test. This is how it works. As simple as that. Now let's see. Let me look at, if I do 8, you guys will be able to do 9. So let me look at 8. 8 says, for the statement below, write the claim as a mathematical statement, state the null and alternative, identify which represent the claim. So when you read, first of all, we're going to highlight keywords. The standard deviation, this is my population parameter. The standard deviation of the base price of a certain type of all vehicle is at least, it's at least, what is at least? At least is greater or equal to, right? So they're saying that the standard deviation of the base price, right, of this vehicle is at least means is greater or equal to 316. So you have a statement of equality. So this has to be the null, right? At least. So that has to be the null, at least. So our choice should be C. So this guy is the null. It contains a statement of equality, at least greater or equal to. So now the complement of it will be what? Less than. Now we all on the same page, less than. So choose the correct null and alternative hypothesis. So this guy has to be the null. So let's find it. Here, D. Here we go. And finally, identify which is the claim. All right. The claim at least is the null. That's what you read. That's your claim. The standard deviation is at least 316. It's the null. So the null hypothesis, yeah. So the choice should be F. This is your claim. That's what's in this guy is what we call the claim. That's what's in the claim. The null. All right. So you guys can do 9 on your own. Now let's look at 10. If I can do 10, you guys can definitely do 11. Okay. It says describe type 1 and type 2 errors for a hypothesis test of the indicated claim. Remember what type 1 error is. Type 1 error is rejecting the null when it is true. That's type 1 error. I reject the null when it's true. So it says a shoe store claims no more than 40% of its new customer will return to buy their next pair of shoes. Or what it's saying is that the proportion of people, of new customer that will return to buy the next pair of shoe is no more than 40%. What does no more means? Think about it for a minute. No more means what? Less or equal to 40%, 0.40. So this guy is the null and is also the claim. That's no more. So my type 1 error is rejecting that statement when in fact it is true. Right? Rejecting the statement when it is true, meaning that I am rejecting that the actual proportion of the customer that will return to buy the new pair of shoes no more than 40%. I'm rejecting it. So the type 1 error occurs when the actual proportion of the new customers who return to buy their next pair of shoes is no more, but you reject it. That's what the type 1 error is. That's what the type 1 error is. Type 1 error is rejecting the null when it is true. And the type 2 error is what? Failing to reject the null when it's actually false. Failing to reject the null when it's actually false. So, failing to reject the null when it's actually false. What does that mean? It means that that proportion is not it. It means that it might be no more. It could be what's not normal. The type 2 error will occur when the actual proportion of new customers who return to buy their pair of shoes is more than, no more. So the other statement will be more than. It's more than 40%, but you fail to reject it. That's what. So type 2 error is failing to reject the null when it is false. So that statement will be false if what? If the probability or the proportion of new customer who buy the next pair of shoe is more than 40%, but you fail to reject it or you fail to say it. If this guy, so if that proportion is more than 40% and you fail to reject the null, this is your type 2 error. So let's go and find it. Okay, our choice should be what? The type 2 error will occur when the actual proportion of new customer who return to buy their next pair of shoe is more than 40%, but you fail to reject. So this is it. This is it. Everything else doesn't work. Less than doesn't work. Less than doesn't work. More than, but you reject. See, this is how I know it doesn't work. It has to be more than, right? This sign, and you fail to reject. Fail to reject because that's what's in the statement. So know your definition. Know what a type 1 error is. Know what a type 2 error is. If you don't know, you cannot do this. You cannot solve this problem. You know what each type of error is. And then you need to know, okay, this claim, no more than. This is the null hypothesis. More than. So you need to know how to write your null and your alternative. These are my keyword. These are my keyword. So I did 10, you can do 11. Let's see. Let me look at 12. It says state the null and alternative in words and in symbol. Then determine whether the hypothesis test is left tail, right tail, or two tail, the nature of your test. Explain your reasoning, sketch a normal distribution, your normal sampling distribution, shade the area for the p-value. Perfect. A security expert claims that at most 20% of all homeowners have a home security alarm. So the proportion of homeowners that have a security alarm is at most. At most means what? Less or equal to 0.20. So this is the null. This is the claim. So the alternative, we know it's the complement. So you flip that sign, right? We flip it, it becomes this. So this is what we have, the null and the alternative. When you read a statement, if you hear a statement of equality, then you know it's the null hypothesis. So the null hypothesis for sure is expressed in this. So state the null in words and in symbol. So let's figure out which one works here. The null hypothesis expressed in word is the proportion of all homeowners who own a home securely is at most. Yeah, it works. So this guy works. This guy is not going to work. This is not at most. This is different. This is equal. Doesn't work. So it has to be A. I hope everybody saw how I did that. Let's say state the alternative. We need to find the alternative. So we go back and we look for this sign. It has to be a greater than sign. That doesn't work. Greater than sign is this guy. Okay? This is the sign that works.